Welcome everybody to our 10th Computing Education Research Seminar of 2025. I cannot quite believe it's late in the year already, and we were complaining about how dark it was outside. But I'm sure that there are people here from all sorts of places. There's someone in America, so it's probably not dark there. So I'm Jane Waite, I'm chairing this session today, and in this series we're focusing on teaching about AI and data science, and we're exploring research that examines what students should learn about AI, machine learning and data science, as well as the most effective ways that we might teach these really important topics in school. So today I am so excited to be able to introduce Karl, who I've met several times at different conferences. And I saw him present about this a little while ago and thought it would be wonderful to showcase it with a wider audience. He's going to lead the seminar on using the microbit to learn about ML, machine learning practices. And if you're interested in what's coming up next, please do look at the website. So, as I said, I am so pleased to be able to welcome our speaker, Dr. Karl-Emil Bilstrup. He's a postdoctoral researcher and interaction designer at Copenhagen University. Karl is part of the Centre for Computational Thinking and Design at Aarhus University, where he completed his PhD on designing educational tools to teach machine learning in secondary education. And he really has been so important, or his contribution is really significant in terms of the work that he's done on embodied interaction for learning and the way that this has all led to the design of CreateAI, where he's worked and collaborated with the Microbit Educational Foundation, which I think CreateAI is becoming increasingly important in the work that we're doing in schools. And in today's session, Karl-Emil will introduce mlmachine.org, which is the precursor. So what came before the microbits CreateAI? And I think it's always important to understand the lineage of these things. And he'll show prototypes of tangible interfaces and embodied activities that help students explore data processes and machine learning practices. And what's really important, I think, is the way that he unboxes. He kind of lets us look inside of kind of the technical issues around modern chatbots. Karl-Emil will also share insights from his collaborations with teachers, schools, and organisations to bring these tools into classroom practice. So I'm very much looking forward to this, and I hope that you'll all enjoy it as well. So over to you, Karl-Emil.
As Jane said, I would talk about how I have worked with developing hands-on tools and activities and work with different embodied approaches to teach about machine learning in lower and upper secondary education. And yeah, I am a postdoc from the University of Copenhagen in Denmark, and Denmark is like right above Germany and right next to Sweden, if you don't know. So not that far away from the UK. And my background is in human-computer interaction and interaction design research. And then from there, I have moved into education. So that's like where I come from and where I work with. So I focus a lot of these tools and how students and teachers can engage with AI and machine learning technologies through different interaction forms. Today, I will say that I work in this area of AI literacy that have become so, have got so much attention. And yeah, I work with these different tools, and I think it's important to know that I work with non-programming interfaces and activities to make machine learning more graspable and explorable. And it's also because in Denmark, we do not have any dedicated subject to teach computing education. So it is about, so our approach is, okay, if we want students to engage with and learn about these new technologies, then we have to make the very accessible interfaces. I also worked a lot with how to integrate these tools and methods into classroom practices and different high school subjects, and also collaborated with different partners. For example, the Microbit Educational Foundation on how to disseminate like these new embodied ways of engaging with machine learning, and into the classrooms. So today I will talk around CreateAI, how our more explorable research here exemplified in these two physical boxes we call the machine learning machine. I will talk more about them later, have actually resulted in a CreateAI that is now used in classrooms. So it's also about this connection between research and practice. So to give a bit more background on where I'm coming from or where I started. So I started in Aarhus in the Center for Computational Thinking and Design, where we work with this idea of computational empowerment, where we want to sustain students' agency in like this digitized world. And we work with this idea that we want students both to be able to encode, as you can see on the model, like new technologies. So design and create new technologies with intention and purposes, but also to decode the technologies they use in their everyday lives. So it's a lot of this, call it a literacy approach, was like, well, are these general competences that students need in this modern world we live in? So I will start with this project, which is quite far away from CreateAI or ML machine, but it's my motivation, we can call it, for why I started looking into this embodied and hands-on approaches. So from this computational empowerment perspectives, me and one of my colleagues wanted to explore, okay, how can we design activities that prompt and scaffold students in exploring the ethics around machine learning systems? So we developed this workshop format with different cards with the data and different interaction forms, and who are the users and other stakeholders who are impacted by this, by the machine learning system that we then ask the students to design. And in these workshops, we had several iterations. We typically ask the students to design a system that somehow could help themselves and their peers. And in this first iteration, what we experienced was that because students did not really understand what machine learning was, machine learning became this magic that they can like sprinkle on the ideas or the problems they identified. So for example, so here's an example where the students have designed this system that should help plan their lessons at the schools and the study trips. And we have these ethics cards, the green one you can see, and we use them to like prompt the students to consider the ethics. And what we got out of this, you can see the note here that is translated, was that the students want to create an algorithm that plans the lessons and study trips in a humane and stress-free way. And this is a good intention, but it does not really specify like what humane or stress-free means, and it does not say anything about how will they achieve this or what are the implications. So based on these experiences, we try to push the students to, okay, you have to be more specific about what do a machine learning system do and how does it work. So in the next iterations of this workshop, we introduced this machine learning model template that you can see to the left, where we had the students specify, okay, what are the data you use in the system? How do you collect this data? How do you model it? And what does your machine learning model output? So they became really specific, and we also used these wireframes. For example, if it was a mobile app, they used You still have to go down in all the design decisions. And yeah, and we still used the ethics cards or the different, and also the other cards around this. And what we experience now was that when we ask the students to consider different ethics, it could be about the data privacy of the application. It was suddenly not so easy for them to come up with solutions to how to solve these ethical implications of their systems. So, for example, we had these students who had conceptualized an application that should help lonely peers by recommending possible friends to them. But they ran into these issues that they had to collect really personal and private data from the users of these applications. But if they did not collect this data, then it would be really difficult for them to come up with good recommendation of possible friends. And as they ended up concluding was that, okay, the more lonely these people or children using the app are, the more motivated they will probably be to share this personal data. So suddenly they were in this situation where there was not really any ethical solution. They have to choose between make the trade-off. Do we want to make better recommendations, or do we want them not to collect this private data in our application? And we were pretty excited about how we saw, okay, that by coupling these ethics to like the technical implementation of these systems the students build, we got like to a whole new level of discussing ethics in the classroom, and also how it became these ethical dilemmas that could not really be solved. The students rarely succeeded in these design workshops, but instead we focused on the ethical discussions around them. But we also had to admit that we were working with high school students and often third year high school students, and the workshop probably only worked really well when I and my colleague were there to like scaffold it. So we wanted to explore, okay, how can we make better activities and interfaces that engage students in exploring these practices and define the machine learning systems without them having to start doing programming. So now we get to the machine learning machine system that I mentioned earlier. So with this prototype, we wanted to like go all the way and see, okay, how tankable and graspable can we make the process of training a machine learning model? And we built and designed these two physical boxes. The machine looking like one to the left is called the trainer, and the other one, which look more like some lab equipment, is called the analyzer. And with this system, students or children can build simple machine learning models to recognize different drawings. So I have this example here where children are training a model to recognize moons from suns, and they draw different examples of moons and suns, and then they feed it into the trainer. And here I can see that when they feed a moon, they slap the red button, and when they feed it a sun, they slap the green button. And in this manner, they build up this data set. And then if you look carefully, there's this black thing also on the box, and it's actually this physical item that they could then plug out of this trainer machine, and then they could plug it into the white analyzer to test and analyze this machine learning model that was then built based on the data set they have showed. And here they could put in new drawings of suns and moons and see, okay, how how does this model we have built classifies these suns and moons, and what happens if we move the drawings around or if we put shadows on them. So the idea was to like have these physical boxes that actually place machine learning in the physical classroom, but and also to make it like really accessible with a low floor. So you can see with this system, students can actually build their first machine learning model without having any idea about what machine learning is. They can just like go to these machines and try to explore, okay, what are they doing and what happens when I feed it some drawings and test it. And then they will actually have built their first machine learning model, even though they may not really understand yet what they're doing, but then through experiments they can start to like deduce what is this system doing. We also wanted to move away from so at this point, for example, teachable machine already existed, and while we saw teachable machine as a tool that was really good at demonstrating the capabilities of machine learning models, that you can like build really effective and working models where we quickly collect data. Here we aim for this slow interaction with the machines, that it really takes time to feed in each drawings, and you have to press these quirky buttons. But it also really gave opportunities for the students to reflect on what is going on here, and they can stand around the physical boxes and discuss what does it mean if I do this or do that. Oh yeah, and we also saw how working with these boxes also give opportunities for students to experience some of the challenges of developing machine learning systems. So, for example, we saw with unintended biases, and with unintended biases, I mean that when you train a machine learning model, you want it to find some patterns in the data that you are showing it. And for example, if you are training a model that you want to recognize suns from moons, then you probably want the model to look at the shapes of the drawings you are making. But here we have an examples with the suns and the moons, but we can then question, okay, what happens if we show it orange moon? Have we actually trained a model that we have unintended bias to look at the colors of the drawings instead of the shapes of what we are drawing? We also had examples with the data representativeness, and that's a question of does the data that I'm showing my model actually represent the problem that I want the model to be able to solve? And here it can be that we want the model to recognize half moons, and we have all these nice examples. But what happens if we have a moon that is facing in the other direction? Does it not count as a half moon? So does our data set actually represent the problem? So we did also experience certain limitations with this system. So the the first one is that when we interviewed the children and the students afterwards, we we saw that it was actually quite difficult for them to relate these experience with these boxes to the machine learning systems they meet in their own lives. So we had like placed machine learning in the physical room, and they could walk around and experiment with the boxes, but it was still like these abstract mystical boxes that did not really relate to anything other in the world. So we had this like new abstract picture of machine learning. Um, we also had colleagues that criticized that we have created this like dance around black boxes that, of course, students could now experiment with the machine learning process, but they couldn't really look inside these boxes. They could actually open the big box and look at the electronics, but it did not say so much about the machine learning stuff going on. And you can both say that, okay, it's right that they're just dancing around these boxes are not actually opening up the technology. But you can also argue that when you're training machine learning models, that's actually kind of what you are doing, that you are training these machine learning models, and then you're testing and evaluating them to see how they perform, and then you are going back and iterating on on the model. So you are like dancing around looking into the actual model. But we did try to open up the black box a bit. So we designed this companion, did we call it, which is a web app that you have on your phone. And then we added these QR code on strategic places on the physical boxes. And you could then scan the different QR codes to get extra information about what was going on in this part of the process. And for example, if you look at number 2 with the QR code right next to the buttons, you can scan that, and then you could see how the drawings you had fed the machine was actually processed by the system and showed to the machine learning algorithm. And if you if we look at the number 7, you could scan that QR code right next to the prediction button, which gave a prediction of the image you were showing the analyzer. You could see, okay, which pixels are the model actually using to make this prediction, like saying, is this a moon, or is it a sun? And here it looks quite all right that it's looking on the drawing, but if it's focusing on some random pixels in the corner, then there are probably some issues with the machine learning model. So this gave students these opportunities to like opening up some more complexity of the models, like when they did some experiments with the tangible interface and there was something they couldn't really figure out, then they could use this companion to get extra information. But when it got too complex, they could just like put it away and then focus on the physical interface, because the system still worked without this companion. So we have this nice switching back and forth. Yeah, you can look at it as you have this very concrete embodied interaction, and then you can move to this more iconic representations of what's going on to add a bit more complexity. And then the next step would be to work with the actual math. Okay. And now to ML machine. So we were quite happy with our work with the physical boxes, the machine learning machines, but we also had to admit that it was not really something that could scale out into the classroom. We could really produce a bunch of them and then bring them out to the classrooms. So we tried to build a new version of this systems that had some of the same qualities, but used materials and technologies that could actually be used and applied in classroom teaching. So in Denmark, they have Chromebooks in all the classrooms. So we know, okay, they have, we can use them. We also have microbits in the classrooms. And then we also was like, okay, and then we can use like different physical existing objects in the classroom to get this more tangible embodied approaches. So yeah, so we built ML machine, which I will show a demo in a moment. And I think I almost already said this, but yeah, the idea was to have these moderate hardware requirements and have this quick setup. We still wanted this idea that you can build your first machine learning model within 10 minutes and without really understanding what machine learning is. And then that you can have a whole classroom using this system at the same time without it breaking down. So, and for those of you who do not know ML Machine or CreateAI, I will quickly demonstrate what it is. This is ML Machine, and it's a web page that you can access as public available. And it's also a tool that you can use to build simple machine learning models to recognize different gestures or different movements with the microbit. And when doing it by using the accelerometer in the microbit as data input. So the first thing I want to do is that I will connect my microbit. And if this was the first time, I would download some software to the microbit, but I've already done that. So I'll just connect it. And can you actually, you can almost see the pattern, but I can see that I have to change the pattern. So this is the name of the microbit that I set here. And yeah, it looks right. And this is to ensure that students are not connecting to each other microbit. And now I connect it with a Bluetooth. And yes, and we can see now it's connected, and we have this incoming stream of accelerometer data that is coming in, and we can see if I'm turning the microbit around, there's some gravity that it can measure, and also if I'm shaking it, so that I'm shaking in another direction. So okay, so we can say that this data can say something about how I'm moving this microbit around. And I'm just gonna clear this so we start from scratch. Okay, so to demonstrate what this tool can do, I will make like the most simple example also, so hopefully will succeed. That is that I will make a model that can recognize if I'm holding the microbit still or if I shake it. So now we have these two classes, still and shake, and we want our machine learning model that we are going to build to be able to recognize these two classes. Am I holding it still? Am I shaking it? And at this point, the system have no idea what this means. So what I do now is that I will show it some good examples of what it could look like. So I can start with still, and I can select it, and now I will do some data sampling or recordings of what does it look like when I'm holding it still. And click here, and instead of clicking this button, I can also just click one of the buttons on the microbit, so we'll do that. We have one more here, and I'll do the same for shake, and that's the same, but now I shake it. So we have one example. And you may notice that I'm making very similar movements and that to help myself succeed in building a working machine learning model in the first try. So, all right, so now we have our two classes, still and shake, and we have 4 data samples in each. And the next step is that we want our machine learning model to analyze these data sets for patterns that it can use to recognize holding the microbit still from shaking it. So I'm clicking train model, and I'm waiting a bit, and it's training the model. And now I should have a model down here that we can see it's okay, can say that I'm holding it still. And if I'm shaking it, yeah, it can see. Right. So that's the most simple example. And now I could go back and add another class. It could be that I'm moving it in a circle, and then I will probably not succeed in the first try. But if I did a few iterations and went back and looked at my data and added extra data samples, then I could probably build a pretty good model that could also recognize shaking it from moving the microbit in a circle. And I will just quickly show that I can also use this machine learning model as an output in a system. So I can say that I will connect an output microbit. I'm going to use another one. And I'm going to change the pattern again. And then hopefully it can connect. Okay, and then I can say when I'm holding it still, this is the output, and when I'm shaking it is we have some noise. And then I don't know, can you actually see I almost, so now I'm shaking it, and as I'm holding it still, yes, it goes. So it's just to very simply demonstrate how I can use this tool to build simple interactive systems. For those of you who wants to open the black box a bit more, there's this hidden filters bottom up here, and I will not say so much about this, but it's just to demonstrate that there's also some more complex representation that you can inspect, and what will I say cool thing here is that this also updates live, so you can do this embodied exploration of, okay, what does these visualizations actually show? And these are pretty complex visualizations, but you can actually explore them and make sense of them by trying to do experiments where you move the microbit around and see, okay, how does these change? So one of the first thing we did when we had built ML machine was using it for different design activities, and which was a thing that was not really possible with the physical machine learning machine boxes. So here's one example where we went to a second hand store, and then we brought the weirdest and most random items we could find, and we also brought this big suitcase that we could put them in. And then we went out into the classroom, and we presented ourselves as representatives of this fictional Fujips firm, which had all these different products, the items in the suitcase, in the product portfolio, and they have heard about this super cool machine learning technology, and they wanted to integrate machine learning into all their products. So that was now the students' task to try to do this. So how could they improve or augment or just completely change the purpose of some of these items through machine learning? And students build like all these different tools, both some of the more obvious ones, like here's this tennis catcher that can recognize if you're doing a forehand and a backhand, and then they have to do these movements to show it as example to ML machine and train the model, and then the microbit could show patterns and say different sounds compared on which type they did. There were also students who took these clocks, and then they trained them to recognize different dancing styles. So it could be tango or salsa or waltz or hip hop. And the cool thing here was that they actually went out in the school and tried to find people who could dance these different dancing styles. So, for example, they knew that one of the other teachers could dance tango, and then they went out and they had her show example of tango moves that they could then use to train their clocks to recognize tango steps. And there was also this frying pan, which could recognize if you were flipping your pancakes correctly, which was really stupid, but these students actually went out and built this cardboard pancake, and then used it to flip, so if they could see if it was flipping correctly, and in that manner they could make a pen that could yeah, say, okay, you have to have the correct flip in your hand right now when you're trying to flip your pancake. Yes. So with this tool, we have we have argued that it both enable students and teachers to enacting machine learning practices, um, as I just demonstrated, as also come from the physical machine learning machine boxes, but also how you can using machine learning as a design material, and last this embodied exploration, which of course plays together with the others. But the idea is that we try to take this different research and then put it into this toolkits that can actually be used in the classroom. I also like to think about it um, like how students work with these different representation and abstractions of machine learning at the same time. So, for example, when they're working on the frying pan, they both have to think about this physical artifact that they're trying to redesign, and the system actually have some purpose in the real world. But they also have to think about how they're training a model to recognize bodily activity, and they're looking at these data visualization and the interface to inspect the accelerometer data. So it's like how they can move back and forth, like the very embodied and design activities, to actually looking at the data in the interface and reason about that. So right now we have these different versions of this machine learning machine toolkit. We both have the mlmachine.org with that, which I just demonstrated. We also have a math version, which is in development, but demonstrate a bit more complex aspects of this machine learning or the practice of training a machine learning model. And we also have open source GitHub repository that you can also go in and fork this code base and yeah, and do new stuff with it. And of course, you're also welcome to contribute. And just to say a bit more about the more complex math version. So as I said, this is in development, but I will say that it is stable enough to use in a classroom. It just not have the same finish and usability as the other version. But here you can actually open up some of the training process. You saw that I clicked on the magical train model bottom in the middle of the screen. But with this version, you can both train a neural network and a k-nearest neighbor model and actually see both, okay, how is the neural network trained, and you can also explore this k-nearest neighbor type of machine learning model and see how it actually make the predictions. So this is to open up the system a bit more. Yes, and as many of you may know, Microbit also created their version of this tool called CreateAI. And this, I will say that their version of the tool is targeting a younger age group and is a bit more simplified. But what is really cool about their version is you probably didn't think about this, but when I just demoed ML machine, all the machine learning stuff was actually happening in the browser, so on the computer. So every time I did a movement and and the machine learning model made a prediction, the data actually went to the desktop, who then analyzed the data and sent the prediction back. But Microbit have actually succeeded in putting the machine learning model on the Microbit, so you can build a machine learning system, and then you can actually take your Microbit and go out in the world away from your computer and use this machine learning system that you just built. They also have a better integration with make code. I think I have to admit that. So also if you want to do more programming activities, maybe look into that. So, but I will say that version is the more stable, simplified version. And if you want a more experimental version, then look at mlmachine.org. And yeah, and if this is the first time you work with machine learning and maybe just work with this system, then I can recommend these very simple activities that Microbit has created. For example, as this activity where you train this teddy bear to have different reaction depending on you tilting it or laying it down. Or yeah. So a very good introduction to the tool. Okay, so I think I will also say a bit about how we have worked with developing material around ML machine. So as I showed in the beginning with the ML ethics cards workshop, we have this focus on, okay, how can we prompt and scaffold critical reflections through these embodied activities? And we have collaborated with the Danish Broadcasting Corporation about developing this material. So it's in Danish, unfortunately, but with this material, we had tried to do some of the same things and say, okay, how can students through mlmachine.org experience these challenges of developing machine learning systems? And we have with unintentional biases where we do similar activities like the suns and the moons, where, okay, does your system actually recognize the patterns you want it to recognize? For example, if it's recognizing circles, have you drawn all your circles clockwise? Then what happens if you do it counterclockwise? So are there some patterns that the system are looking for that is not really the patterns you intended when you designed this system? And based on these experiences, we work with these different cases. And for example, here one case is undesired content on social media, which is something that the students can relate to and all have experienced. And we discuss, okay, why does it happen that there are harmful or violent content on social media? It may not be because there's a person somewhere who have decided that this should happen, but because there is a machine learning model designed to identifying certain patterns and optimizing for certain behavior that then result in harmful or violent content showing up in your feed. So showing how the complexity of machine learning system actually result in experience in the own world. We also have an example with data representativeness. And here, this is a activity where the whole classroom works together. And the task is to build a machine learning model that can recognize different physical activities. They can be like jumping jacks and running on the spot. And the model should work for every student in the classroom. But all the students are not allowed to show this model examples of how they are running on the spot or making jumping jacks. Instead, they have to do a representative sample of the classroom. So if there are 30 students in the classroom, they have to pick 7 students who should be the ones who show examples to this machine learning system. And here they can consider, okay, what should we look at when we make this representative sample? We normally start by lining up all the students by their height and then make a selection based on this. And then you could consider, okay, should you look at their shoe size or should you look at which activities they attend in their free time, their hair color? So it becomes this discussion in the classroom and with the teacher. And this is not an activity I would go out in the classroom. I do not know and do. So it's only activity that the teacher who's confident about his or her classroom and know that this will work can do. But we make this representative sample and discuss, okay, what does it actually mean that the data we show the model represent the problem that we're trying to model? And based on this, we both discuss, one example is self-driving cars. Like we hear about all the self-driving cars in California, but we do not really see them in rainy and snowy Denmark. So how can that be? Could it be that the data these cars are trained on does not really show example of snow and rain and gray weather? And we also have this more critical example that some of you may know. It's an old example, but it actually happened that Google had this image recognition algorithm that tagged people with black skin as a gorilla. And this is also a case where this is not something that anybody had any interest in happen. Yeah, that this should happen. At least we must assume that. So how could it happen that they actually published this system that they did this? And again, it probably had something to do with how representative the data set was. And yeah, and we have done research with many different activities on, okay, how can we expose some of these challenges with machine learning? I've not talked about the impact of parameters here, but very simply, it is like this thing with machine learning systems that you can twerk one of the hyperparameters a little bit, and then you can get completely different results from the machine learning model, which really demonstrate how these machine learning models are not showing the truth, but are some approximation. We have this paper where we have elaborated more on this and where we try to make this argument for how to move from demonstrating the capabilities of machine learning to to engage students in the design decision and choices of developing machine learning systems. And we actually map all the steps of designing a machine learning systems and try to say, okay, what are the design choices that you have to make, and what are the design questions that you are asking? And I would say these are the people from the university being very ambitious about what should be taught in school, but I think it can be used to like show like, okay, what are the things that can be discussed and thought about when you're working with these machine learning system. And we also analyze existing tools that are out there and reflect for each step, okay, what could we do in classrooms to engage students in more of these design considerations? Okay, and one last thing is just if all this example I have showed here's before ChatGPT was published, and I often get these questions about, okay, how does this old school machine learning relate to the chatbots that we are experiencing everywhere right now? And I will just make this short example because I will argue that these concepts and practices that you engage with through these hands-on tools are actually the first steps to start understanding, okay, what is these chatbots and AI systems about? So if we return to mlmachine.org and think about how we have this system that gets this accelerometer data and then outputs a word or a class, and here it's triangle, shake, and inactive. And what's actually doing is that it's analyzing these symbols that in this case is accelerometer data, and then it's making some output. Then we could also think about that, okay, these symbols could also be words instead. So we could have like what is the next word in this? And then we want to put a new thing in, and it could be like sentence. So what I'm trying to say is that like the problem is kind of the same. It's just way more complex because now we have all the words to choose from instead of like these three classes. And this is not, so we could do this, but then we will not really have like a generative system. Like we will not really generate like new sentences, and we're not experiencing it that as being creative or anything like that. But what we could do to improve this system a bit would be that we could look in the mlmachine.org interface, like we had these bars that showed like, okay, how confident is the system in the different classes, on the different classes. And in the mlmachine.org, we just say if it's more, I think it's more than 80%, then it's we are probably shaking it. And if it's more than 80% from still, then we're probably holding it still. But instead, we could use these use these as probabilities. So we say, okay, instead of just choosing the most likely, we could say, what is the next word in this? And then it would be most likely that we chose sentence, but we could also choose book instead. It would just not be that likely, a novel and compound. And then it would be very unlikely that we chose like washing machine and all. So now we will have the system that actually like generating new words each time. And now if we imagine that we have this system, and here I have symbolized it with this small robot, which is our machine learning model, we can actually start generating small sentences. So we could start with as our input, have what is the next word in this, and then our machine learning model outputs book, and then we could shift the frame a bit, and then we could have is the next word in this book, and we can input it again, and then we get about, and we shift the frame a bit more one more time and get physics, and do it a last time and get a question mark, and now we've actually generated a sentence. And of course, this is a very simplified example, but it's just to show how it's the same practices and ideas that lies behind these chatbots that is in these more simple machine learning activities. If you want to dive more into this, I have a colleague, Luke, who have worked with the engine room, which also have these like hands-on and embodied approaches to exploring machine learning and computational system. But here it works with natural language processing, which is okay. How can you generate and analyze text with computers? And yeah, there's both these unplugged activities, and there's also digital activities where you can actually build simple models to generate new text that are actually so transparent that you can figure out what is going on. I think I will stop here.
Thank you everyone for coming along. You can give Karl-Emil a big round of applause. Looking forward to seeing you all at the next one, and have a great evening, afternoon, morning, or wherever it is. And you can turn on your mics now and you can say goodbye.